Chapter 3, Computing with Numbers Using the Math Library. We're on page 3.2, we're on page 60 and 61. Using the math library, they go over the quadratic formula here, and then we've got quadratic.py. So we're going to do quadratic.py real quick. This is the change.py program. We're going to put it in a new file. So let's just have a little fun and sort of go over what this stuff is. So these are the comments. So let's save that as quadratic.py. If you remember this from math class. Algebra 1, maybe Algebra 2. One of the above. All right, so a program that computes the real roots. I think it was 2 for some reason. Doing roots and all that stuff. I don't know. Maybe some of you went to better schools or had better Algebra 1 classes, but I don't think we did this until Algebra 2. So real roots of a quadratic equation. Or maybe we just didn't get to that chapter in time. Illustrates use of the math library. Okay, so first thing we're going to do is import math. And these modules are lowercase. These libraries are not positive. Every single one is lowercase, but it looks like the math one is. Makes the math. And then let's do main. We'll define it. This program finds the real solutions to a quadratic. I'm going to print blank line. Then we'll do ABC. Disk root. Okay, so here we go. So this is b squared minus 4 times a times c. And then root 1 is going to be negative b, right? Because it's plus or minus, it's negative b plus or minus radical b squared minus 4ac. So the square root of b squared minus 4ac is going to be our disk root. And then our root 1 is going to be negative b plus the disk root slash 2 times a, and then the root 2 is going to be negative b minus. So this is going to be plus so 2 times a here. And then root 2 is going to be pretty much parallel. It's going to be minus disk root and slash 1. Now we can use different data types with the comma within the print function. So these commas, we can have multiple different data types or variable types, etc. And then we call the main. So this is our main function. We define it and declare it, and then here's where we invoke it or we call it. All right, so let's check this out. Quadratic.py. Let's check it out. Here's change.py from before. Let's check out quadratic.py. And let's see how it looks. Okay. All right, so the red is our comments. I might want to put my name underneath note, by, I guess I could do that. And then we can save that. And that will save it here also. Kind of nifty. I saved it again. Okay, everything looks pretty good. Parentheses times, open parentheses, 2 here, 2 closed, 2 open, 2 closed. These are separated. There's 2 quotes. I think it looks pretty good. Okay, let's run it. Module line 22. Oh, I put math. So that was the module. The function is main. So we're not calling the math module. We're calling the function. We're invoking the function. So yeah. So that was a little hiccup. And then here we go. So let's just do main here. Save that. Let's run it. And let's do just like the book says on page 61, 34 negative 2, 4.3874 and change, negative 1.7207 and change. Very good. All right, let's do so now the coefficients, if we enter them again, and we run what's on page 62, if we run 1, 2, and 3, we're going to get an error. The error is the math domain error, because b squared minus 4ac is less than 0, and the square root function is unable to compute the square root of a negative number. So Python prints a math domain error here. However, this is one thing that I always remember and remind myself is, at my level today, what is it okay that I know and okay that I don't know? And at my level today, at our level today, taking this class, reading this book, trying to go over all the exercises, we, as Professor Zelle states, we don't have the tools to fix this problem. So we will just have to assume that the user gives us solvable equations. We didn't actually have to use the math library he mentioned. We could just use exponentiation, which is the star star. So that star star. So like 2 star star 3 or 2. So that might not have been, an issue. However, it's somewhat more efficient, and actually I still think we would have gotten the same type of error. In fact, the book says that In general, if your program requires a common mathematical function, the math library is the first place to look. So accumulating results, factorial, on page 62 and 63, pi, e, sqrt, x, sine x, cosine x, tan x, a sine x, a cos x, a tan x, log 10 x, which is the common base 10 logarithm of x, exponential of x, the ceiling of x. I like this a lot. So ceil x means the smallest whole number that is greater than or equal to x, and then floor of x is the largest whole number that is less than or equal to x. Kind of like that. That's kind of interesting. So let's, since we're at the shell right now, let's do this. Let's do fact, and this is on page 64. So fact equals 1 for factor in, and this is just good practice. I like practicing this stuff, especially at this stage of the game, just because, you know, you're relatively new and learning kind of a new subject. You know, it's helpful. So we could do so that's fact equals fact. So you could punch in fact here, 720, because it's going to be fact times factor. So fact equals 1. So it's 1 times 6, and that plugs into, that is assigned to fact. That's 6 now. Now 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is 720 still. So that's why fact is 720, because it's updated here. So fact is 1, and now fact is assigned fact, which is 1, times factor, which is 6. So we start out with 6, and then it iterates through this sort of loop, this list, as it were, that decrements by 1. And so it's going to be 1 times 6 is 6. That gets assigned to fact. That's now, you know, that's, so the fact is now 6. Actually, it's going to be, it's just going to be up here in the ether. So now fact is 6. So it's going to be 6 times 5, 30. Now that now becomes 30. Goes here. Now 30 times 4. Because for factor in this, so for every factor, that's going to be here. So times 3 times 2 times 1. All right, so now let's try fact equals 1. Let's see what we think it's going to be. I always like to guess too before I look at the answer. I like to guess. So what's it going to be? It's going to be 2 times 3 times 4 times 5 times 6. It's going to be 6, 24, 25 times 5 is 125 minus a group of 5, which is 120. So 24 times 5 is 120. 120 times 6 is 720 again. It's 720 again. Because we're essentially going in order without the 1. This goes down in descending order from 6 down to 1. This goes from 2 to 6, but we don't need the 1 because anything times 1 is itself anyway, so we're going to get the same answer. So let's do this. Let's do print fact 720. So same thing. Print fact, and I'm using, let's just check this out, just FYI. Python's integrated development environment, 3.5.2, out of version 3.5.2. This is the shell. Let me get it here, docs.python.org. Very helpful. And then here it reminds us that this is Python 3. Also here it reminds, a lot of reminders that we're using 3. All right, so let's check this out. Let's do list. So this is the range 10, which is 0 through 9. It's going to be 1 less than this range, and it starts out with 0. Computer scientists love 0. They love starting at 0. And Python is no exception. So then here, so let's just guess what we think it's going to be. I mean, even though we can look, but, well, if this is 10, it ends 1 before. So let's say this will end 1 before. So it starts at 5 and ends at 9. So 5, 6, 7, 8, 9. And that's right. But that might not have been the case, you know, but it's just good practice. You know, my thought is that it's good practice that I practice what I think it might be and then see if I'm right or not. And then also it shows me if I'm like learning or not. Now here this is range start, stop, step, which is right here. Range object. So start, stop, step. And so that bracket means it's not required. Right? You can stop, or you can start, stop, or start, stop, step. So we're going to start, stop, step here. No exclamation. So what do we think? Well, it's going to be 5, and then step 3, so 6, 7, 8, and then step 3, which is 11, but that's outside of 10. So once we pass our number here, we're out. Let's try something else. So even though this is in the book, let's do 5, 15, 5. So let's see if it hits 15. I doubt it. I think it's going to go 5, 10. Yes. So remember, it hits 15, but even though this is here, it only goes to 1 less than that number there. So wherever that stop is, it's going to be the stop minus 1 is actually where the range function will stop. So that's good to know. I like to learn that stuff based on the language. So yeah, that was 64 and 65. We're going to go over factorial.py in the next video. So thank you very much.